Cord to this computer. All right, folks. Sorry for that mishap. We'll get started real quick, and I'm gonna start by demoing what I've been working on from the NCP side of things and the NC controller side of things. But anyways, just to kick off the actual recording, good morning, everybody. This is the May 4th CAPN office hours, and today we're going to be going through a quick demo, and then I assume we'll probably talk about a little bit about roadmap, as long as my network doesn't drop. My network really doesn't want to do this today. This is horrible. Sorry about that, everybody.
So you cannot recall?
No, I've got a recording going. I just keep dropping in and out.
Keep the okay.
Just keeps cycling on me, and I don't know. Oh well. All right, I'm gonna share my screen and see if y'all can actually see this. Let's see. It is going to be an incredibly short demo because it's just bringing up a control plane and applying a handful of manifest, and a cluster comes up, as we already saw from Chow last week. But this is basically just the automation of the certificate generation and the cube config generation, and hooking it up so that cluster cuddle will actually work as well. So share screen. I will show our terminal. Y'all should be able to see that.
Yes, I do.
Awesome. All right. So the quick demo here is I put in a pull request that just about 5 minutes ago. It's still a little bit of work in progress. I've got to write some tests for all of the controllers that got written for all these functions. Enter. So I still got to write some tests for this, but in essence, if you want to go look at what actually got implemented, all of that code is up there. And to actually show this, I'm running a bare bones Minikube cluster. Get all -a. Bare bones Minikube cluster, but I'm also running all of CAPI deployed into it. I did not specifically omit any of the kubeadm bootstrap or the kubeadm control plane components. They aren't being used. They're just automatically deployed when you do cluster cuddle init. But in the long run, those won't get deployed without provider because they're not necessary for us to actually run with. So now that we actually have this cluster running, let me actually show you what's in the default namespace, kget all. You'll see that there's really nothing actually deployed into this. And if I do clear that, and if I do kget CAPI, you'll see that there's no components deployed in here. Also capn, just to make sure. And so those are all just our categories for our CRDs that we can actually filter through. So if we go and take a look at what we're actually going to be deploying, we're going to look at the config directory. We're going to go look at samples, and you'll see there's a handful of components in here. Move that aside for a little bit so I can see them all. Okay, so in here we basically have the nested API server, the nested controller manager, the nested control plane, the nested etcd, the nested cluster, and an actual cluster resource. So the CR for CAPI. So if we actually go take a look at what these actually look like, there's some interesting things that I had to implement that I'm still working through how we'll do this long term. But starting with the actual cluster, we basically just have, let me use bat instead. So we basically just have the actual cluster object in here. Right now, I'm specifying the host set to the actual name of the service that gets generated. So you'll notice that this cluster is called cluster sample. The host for that that control plane endpoint is the internal cluster service that it's going to be routing through. And that's because the kube config gets generated using that control plane endpoint and the certificates and the CAs that are generated through the nested control plane. Now we have our two refs. We have our control plane and our infrastructure ref, which actually associate all of the components together. So instead of using KCP out of the box, we're using the nested control plane. And instead of using another cluster CR, we're using our nested cluster. So if we go and take a look at what that actually looks like, just to make sure everybody is on the same page, that nested cluster is very, very basic. And actually, I believe I should be able to get rid of the control plane endpoint that's in there right now. I think I need to be setting that later. But in essence, very bare bones. And the rest of them I have, oh, sorry, let me go show V1 control plane. V1 control plane. So, and the last one is the actual control plane, which is very similar to what Chow had demoed last week, where we basically have the nested etcd, we have the nested API server, and the nested controller manager all as references for that, so that we can set up all the associations for the owner references. Now, I've got this running in another tab because I don't actually have it deployed as a container in the cluster right now. But in essence, this is just running as a Go process separately. And from one side of this, I'm going to treat the right-hand side of this as the tenant control plane once it comes up. And as the left-hand side will be the super cluster in essence. So over here, we're going to do k apply -f. And before I do that, let's do watch -n 0 -1 kubectl get PO. So what we're going to do here is we're going to basically go config samples. We're just going to apply this whole directory. So similar to what you would do after you do cluster cuddle generation of all of these actual manifests in the long run. So we go and apply those. You'll see that they were all created. And you'll see, just like before in Chow's demo, all the pods are coming up, but now we have certificates that are generated outside of this flow. So if I go over to the right-hand side again, I'll close out of this because now we know that the pods at least came up and we're just waiting for it to cycle through. And it's going to go through a couple transitions. And this is the same exact thing that Chow demoed, where it transitions from, you'll see that controller manager errored because it doesn't have it can't validly connect to the API server. Same with the etcd instance, it's going to cycle for a second, and the API server. So let's go look at what we actually generated to make this all happen. So if I do kget secrets, you'll see we have a ton of components, and some of these are non-standard for CAPI because of the way that our control planes are brought up as pods. So if I could filter this, I would. I guess I could have sorted this. But basically what ends up happening is all of the CAs get generated first. So we have the actual cluster CA, we have the etcd CA, we have the proxy CA, and then we have the actual service account for the control plane to come up. And so those are just using the standard functions for generating any of those CAs that KCP actually uses. And then once we have all of those components, we go through, and in each one of the nested component controllers, we call and use that CA similar to what kubeadm would be doing on a physical host typically through user data, or through Cloud Init rather. It's going to go and generate the certs for each one of the components. And so this is where our solutions it's going to have to differ a little bit because it's deployed as a stateful set. We need to generate, and we end up with one single client for all of the nested components based on whichever component is. So controller manager, all 3 pods or 5 pods, however many you want to deploy of it, are all going to have the same exact client certs and all of that right now. But we basically go through and we generate an API server client, we generate an etcd client, a health client, kubeconfig for it. Well, that actually is already generated. We generate a kubelet client that we'll be able to use later from like the VN agent side of things. And then we generate the proxy clients so that you can reference those. And so now if I go to kget PO, this got brought up a bit ago and it was actually already running, but you'll see the cycling that it did. And now, because of how I actually deployed this, one big change that I did from the way that it was set up with from Chow is these now all have very common naming. You'll notice that cluster sample, which is actually what the CAPI cluster object was called, is what everything is prefixed with. So down here we have cluster sample API server, cluster controller manager, cluster sample controller manager, so on and so forth. And it's the same thing for all the services as well, which makes it a little bit easier for us to set up all of the certificates and to kind of like filter through these objects at a per cluster level. And so if we kget service, you'll see that we have the API server, we have etcd, we still are using headless services for this. I switched this over to cluster IP for right now for in-cluster functions. And so to show this actually working, we can go do a port forward. And so I'm just going to port forward to cluster sample. And actually, sorry, before I do that, we're going to use cluster cuddle. Cluster CTL. So I'm going to go and basically run this cluster cuddle get kubeconfig cluster sample, which is going to go reach out and grab this kubeconfig. And then I'm going to pipe that to a local file that's just called kubeconfig. So we can actually take a look at what's generated for it. So I'll do that. You'll notice it pops out some debugging. And if we go do bat kubeconfig, you'll now see that this is the actual kube config that's generated for this local cluster. You'll see where I was talking about how it references that cluster sample API server 6443, which is generated based on the control plane endpoint. And now if I go port forward this, I can come over here and say k-kube config get svc, and you'll see that this cluster is addressable just like a normal cluster would be, and like we would all expect it to be accessible. And so now all of that comes up. We can basically go and recycle this as much as we possibly want. Actually deploy or delete this, and you'll see that all of these things are going to get torn down. So those are all in a terminating state. And so now the cluster can come up and come down without needing any extra components generated or anything generated out of tree or out of Kubernetes at least. Now any of those components as well, because they use a common naming scheme, we can technically replace them. And so all the controllers will check to see if each one of them exists before creating. So if you went and generated a CA or had a root CA that all of your nested clusters are supposed to use, you could supply that in this secret and then also generate all of your own certs off of it and supply those to the cluster as well. And it's just not going to recreate them if they're already there. We do like a lookup against any of those common names before generating. And so you can supply any of your own certificates. For example, if you wanted to use Cert Manager to generate these upfront and then go from there, you'd be fully able to do that. And so that's the quickest demo of that code base. So I'm still writing some tests for this, and there's a pull request up if you want to take a look at it. But that's pretty much where we are with the nested control plane.
Yeah, sounds good. So a few questions. So let me see. What exactly the Nest cluster controller will do?
Yeah, so it kind of just coordinates between the actual cluster resource and it's like the overarching object that is owned by us for how it interfaces. I'm sure there's other functions that I'm missing that it should be doing, but as of right now, that's all it's doing.
Yeah, my understanding is everything that you demoed today, I think the most of the orchestration happens on the NCP controller, right?
Yeah, so the only thing that the actual NC controller is doing, here, I can pop open the code real quick. The only thing that the the nested cluster controller is doing is it's going and making sure that the status is reflected back on the nested cluster, or sorry, on the cluster resource for CAPI. And so let me show you real quick. Nested cluster. I believe that should show Chrome and should show what we're looking at. So in essence, basically what the nested cluster is doing is it's going and checking, it's getting the owning cluster, so the actual CAPI cluster CR, and it's going to go and make sure that it has the control plane ref, and then once it has a control plane ref, it's going to go and update the status, whether it's been, if it's not ready already, and it's if the NCP is set to ready and it's set to initialized, it'll just go and update it so that it's now accessible to other components. And so I believe, and Scott, I think you'd probably have more insight into this, the way that this is going to function downstream is like the cluster resource set. So the thing that can deploy add-ons, for example, is going to check to see if each cluster is ready using that CAPI cluster CR. And so it will, so as long as we set those resources, then this cluster is accessible via other components to start operating on it. So we'd be able to deploy OLM into this cluster using the cluster resource set.
Exactly, yeah. Once the cluster's control plane is considered as up from based off of the moving over of status fields, and initialized, I believe, is the one that it works off of, at that moment, the cluster resource set will attempt to apply the manifests. If it doesn't succeed in applying the manifests, it will try again. So the apply once is until it succeeds to apply, basically. And once the control plane of the workload cluster or the nested cluster accepts it, then cluster resource set stops doing anything, basically. And then it's up to the workload cluster to actually provision the resources. But if you make a change to the config map, this is a newer thing, that if you make a change to the config map or secret in which the YAML manifests are located, so if you wanted to update OLM, if you make a change in the config map, that is considered as if it's a new cluster resource and it doesn't apply again. So you can upgrade later on as well the inserted add-ons by just updating in the supervisor cluster, in the management cluster, the CRS.
Sweet. Perfect. Thank you for that.
Chris,
Yeah.
So do we have a tight coupling between the certificate manager and your written code?
Nope. So this actually out of the box, you can check it out in the pull request. I mean, I could share my screen as well. But in essence, what we did is pulled a lot of the functions that are used from the for KCP. So which is the control plane, the Kubidium control plane provider that is the in-tree implementation for control planes within CAPI. So we pulled a lot of the functions that they do in there to generate certificates and reuse those. Now that doesn't have a hard dependency on Cert Manager, but you can overwrite with any other certificate management you want, as long as you generate the secrets properly.
Okay.
Yeah, KCP allows you, if you pre-create the secrets also with the right names in the right namespace, which is currently the way it's done if you want to bring your own CA, that's the way to do it today as well. And that's fully supported in the functions that they export in KCP.
Yeah, the code path in there, if you want to check out that PR, basically just there's a function called lookup or generate, and lookup or generate goes and loops through a list of certificate resources and checks to see if it exists in the cluster, and it just uses the actual cluster, the cluster CR name as the prefix, and then whatever the purpose is of the certificate. And so whether that's CA, etcd, or controller manager, or any of the other secrets that I showed you that were generated from this control plane.
So are all components using the same root CA?
Nope. So the cluster gets a CA, the front end proxy gets a CA, etcd has a CA, and then we leverage those from the component controllers to generate the clients for them.
Okay. Yeah. Because since Tao is not here, but I looked at his report last week about this project. He said he discussed with you, in order to use the Kubernetes control plane controller generator, yeah, you need to change the syncer, but I don't understand. Is this true?
That is a separate topic that I wanted to add into this. I don't want to have the conversation with Zhao Chao though, because I want to. There's a thought experiment here that that I think we should eventually have. But it can go in parallel with this. I think there's ways that we could leverage KCP a little bit more, which would benefit us by like not having to duplicate all of this work that we've already done.
Oh, okay.
So I wanted to have a conversation of like, okay, if we were to take this, there is some change. I'll quickly explain what I sent to Chao, which is basically if we were to take 5 steps back and look at what KCP actually does for us. It generates a bunch of certificates for us. It generates the kube configs. It generates the RSA token for the service account, so on and so forth. Then where it actually leaves us off, we are able to, or what typically happens is it paired with machines within the cluster will go and apply, or will go and configure Cloud Init scripts that get provisioned onto VMs, for example. So user data is going to have a Cloud Init script. It's going to go and provision the actual the control plane on each one of the nodes. And so there's a a potential here that we could leverage some of this and write a custom machine controller, which is a standard thing for every provider to do, where we would be able to leverage CubeADM from the actual spec and definition side of things, as long as we could then in a machine controller have, this is where it gets a little bit weird. We basically can do something where we would fake machines into the clusters, into the virtual clusters. And this is where it requires syncer changes. There's so many pieces here. I think I have to write this up, but in essence, what we would do is, instead of having a bunch of controllers managing all of the components, KCP would go and be the definition of it. We'd have a machine controller that goes and you'd have to deploy a machine CR. That machine CR would then reference a virtual node within a control plane or within a virtual cluster. And those have to have a mapping, and that's where it gets really crazy. And once you've done that, you can set up a control plane node, which is where the control plane components would get deployed. Now, we're obviously talking in virtual cluster, so there isn't a single virtual node that is potentially running your control plane components, because it could be spread anywhere. But we could fake that because we have full control over the node object. So we could create a control plane node provider, for example. It drops a node on there. That node ref gets synced as the node association for any control plane pods that we would then have to populate in the nested clusters. That's where it also gets weird, is now from the Cube system namespace, you would have a faked pod or potentially a real pod, but it's like synced in a weird way. And so that would make it so that KCP could actually have all of its functions. And where I'm going with that is what KCP needs that I learned about that makes it kind of difficult out of the box for us to use is, if you were to do this, if you use KCP, it does health checks. And it does a health check, for example, against etcd. And to do a health check against etcd, it does a kubectl exec. So it uses its admin credentials to kubectl exec to typically what is a static pod on a physical host. It goes through that loop. Now, if we could basically fake that by putting the KCP control planes in, or the pods in the Cube system namespace, and still have it accessible, we in theory could leverage a lot of what KCP's already done. So there's some weird things in there, and it would need a big exploration, and it's a parallel effort for sure, and doesn't need to derail this. So
basically, you need to fake the all environments that the KCP keeping KCP's mind about the whole thing looks like. Then, because they have an assumption there, it's not like plugin kind of thing.
Exactly. And there's some benefits there. I mean, if we did that, we'd be centering around CubeADM spec. We'd have the cluster configuration spec that they already have defined. It's the same thing that's in kind clusters, for example. And so there's some alignment pieces that are nice.
I understand. Okay. So
there's other pieces as well that I think make this difficult. Like currently CubeADM only outputs CloudInit scripts. You can technically, like on the CloudInit scripts, it goes and generates static pods. And so I want to find out if there's some hooks within CubeADM that we could go and output the pod template, the pod specs, the static pod templates. If we could go and grab just what we need to create a pod template that we could inject into a stateful set or a deployment, then we could do some really cool things where we're basically saying, we're not going to do anything except for just grab the outputs from CubeADM and apply them. Yeah. It's a lot though. So
yeah, I think so the real benefit is you can leverage all the KCM's the code around the management of the certificate. So I believe they have something to handle the cert update, cert rollout, cert kind of installation.
Which I brought over, because I mean, in essence, like KCP was the inspiration for what the whole nested control plane looks like. So I brought over a lot of it, but it's just that we now have to maintain it ourselves. So like, if you go look at the how I'm generating certificates, the lookup or generate, those functions behind the scenes will check to see if anything's expired. And at a 6-month life cycle, it'll automatically refresh. The out of the box, the certificates are allowed for a year. And then after that year, or after 6 months in KCP, it expires them and regenerates those. And so I use those same exact functions. So in theory, we're getting the same pieces out of it. It's just that we have to maintain that ourselves now.
So you're forking now. Okay. But this is not a blocker, in my opinion. Right?
No, separate, completely parallel for sure. And could be something that, like, at the end of the day, we're just bringing up control planes. This is all just interfaces for bringing up these control planes, and it shouldn't stop us from doing what we're doing now.
Okay, now I understand it, because I don't understand why we need to introduce the dependency which is required.
Yeah.
Okay.
Yeah, I really was trying to avoid that, and but brought it up as like a, hey, this is kind of interesting thought experiment. Should we talk about this? And Chao was like, yeah, let's talk about that on
Okay.
next Tuesday. So
Okay, let me see. Another thing is about sidecar. You use sidecar to manage its life cycle of certification.
We're not actually doing that. So that's where the nested component controllers are doing it. So this is where I was exploring what, like, the paths around how we could generate client certs for each one of the pods that get generated. So now the caveat that I said early on in here was the nested control plane generates the CAs. Then the nested component controllers now create their client certs.
Yeah.
But because we set a replicas on an orchestration object, like a deployment or a stateful set, it's using the same exact certs for all n replicas of that. So if anything were to happen, the identities are always going to be the exact same. There's no like ownership level of the identities behind those certs. And so the conversation I was having with Chao about that was, okay, are there ways that we could get around this where we can have each pod come up? And the only way that I could come to do this would be, okay, similar to how CloudInit works for kubeadm, in a sidecar pod, generate the certs every single time the pod boots. Every time the control plane, the API server or etcd boots, grab the CA, generate the cert, and then put it in the file system where it needs to be. Which saves secrets, but yeah.
Okay, I see. So I think your requirements, if you have 3 copies of the control plan to do the redundant to prepare for the failover, all 3 pods will have the same cert. So you guys want each pod to have different certs. Is it what you want?
I mean, it's not a hard pressed thing. It's just, it's the way that default things work within CAPI. They automatically have different certs because they're automatically generated on a VM boot, for example. So it's just a different implementation, and not saying that it's technically wrong. In our actual implementation of this, it's going to be a little bit different because we manage certificates vastly different than this.
I'm actually curious how they do, because they have 3 API server copies, they will have 3 different certs.
Same CA, but different client certs.
Same CA, yeah. Okay, same CA, different certs. Okay, I see.
Yeah.
Yeah.
And so that's the thing, is like right now the identities on each one of the API servers, if there's 3 API servers, they're all going to be the same if they're certificate based.
Oh, I see. But because they use VM, so each API server just one VM. So every time they create a new VM, they just definitely need to create one cert for that.
You got it.
API server. Okay.
So I mean, like, not a blocker for right now. This is absolutely something we can just move forward with. Did I lose y'all?
Hello?
Okay, cool. I think I'm back.
Yeah. Now I understand what you're talking about, because the original one, every control plane, every new API server, they will pretty much start a new VM anyway. So every time they put up a new API server, they will create a new cert. But we are using pod, so we are coming from the same stack, from the same stateful set. Interesting. Okay, now I got it.
Yeah, it's a little bit of a weird implementation. I mean, like, it works. There's nothing wrong with it per se, other than like we're treating every pod as the same. So I'm thinking about like upgrade strategies here as well. Like, what is this going to affect long term? Especially because they're not versioned client CAs or client certs. So like if you update one, it's going to have to refresh in all of the components. So every single one of those components, which Kubernetes is good about. I mean, I'll give it that at actually watching certificate directories and auto refreshing for you, and usually clearing clients. Like it's relatively good at it. So I'm not super worried about it. And these things are not immutable secrets right now, which would cause, I mean, that would cause a huge problem if all of these these client certs were immutable secrets.
Yeah, I actually, I never thought about it. I even don't know how that works. For example, you have 3 etcd copy, you have 3 API server copy, and all 6 pods will have 6 certs, but only certain mappings will work, right? You need to tell every time if there is a failure, you need to tell the other there is a search change.
Mm-hmm. Yeah, luckily, a lot of these components are doing like I mean, in controller runtime, we have a cert watcher package, and I know this is implemented in core Kubernetes as well, where it basically just does an FS watch on on whatever the cert directories are that you specify, and it does a refresh. I mean, it goes and clears all the clients and does a refresh for you. It's just more a matter of like, there's always the potential of something happening. If it does a cert refresh and the cert doesn't work, hopefully that's handled. Like there's so many other edge cases that we need to be able to think about, where like where VMs, you have a whole new entire deployment and you don't have to think about those kind of functions. So it's just things that we have to deal with. And like a sidecar would solve this. A sidecar treats this very similar. And as long as you, a sidecar would solve this to some degree. If you refreshed things, then we need to make sure that the sidecar re-kicks and does things. So that sidecar would actually have to be like a full-on process that's doing some certificate watching. There's so many pieces there. So
interesting. Okay, actually, I can ask this is a very interesting topic. I can ask our internal guys how they handle this. I don't know if they use the same certs or different certs but different copies.
Are you on? Are you running pod-based control planes or are they VMs?
Definitely pod.
Oh, okay, cool.
We use pod-based management.
Oh, sweet. I thought I didn't realize that. Okay, cool. I thought the control planes for a lot of what you were doing was all in VMs in Ollie Cloud. That's awesome.
In VM, but we put, so it's still VM, but it's kind of a big VM. You have one VM. You have same power.
Okay, cool. Sweet. Yeah, if you can find out what your teams are doing,
I would
have
3 copies in one. This is I recall that probably, yeah, but I need to double check. Maybe they have exactly like one control plane, one VM. That's also possible. You have 3 VM. Or you have one big VM, but you put all 3 copies in one big VM. That's also possible, but I need to double check. If you separate VM, probably separate certs. That makes more sense.
Right.
But if you have 3 copies in one VM, I don't know how they handle it.
Yeah. I mean, I would assume that, like, I mean, in a typical CAPI deployment, these things, or I mean, a typical QADM, whatever, what have you, all of these deployments, you're going to have something where you could, like, etcd is probably going to be completely separate. We're going to have like an Esther, well, although that's a feature that's still somewhat being developed within CAPI right now, but like I'm assuming y'all have an external etcd cluster, and then maybe your control plane components are just the scheduler, controller manager, and API server that you're actually working with, or not scheduler within VC at least. But.
Same thing. We definitely support multiple copies of it. So yeah, that's good. Okay. Yeah. Okay. I probably will check internally to see how they handle this. But I think that's a very valid point. About
it's interesting.
Yeah. We
cool.
Never about that before.
Yeah, we didn't. Yeah, in VC Manager, and like none of the, we just kind of went, or the path is just like, all right, just use all the same certs for everything. And realistically, we're not really spreading a super ton. So
probably okay, but if you keep, probably okay in the initial usage, or but it all depends on the trade-off. How difficult to implement that?
Right.
How complicated to implement that? Adding a sidecar is, I don't know how many.
It's more about the process that's running that sidecar, and then doing the lifecycle management of the sidecar is going to be probably the more difficult piece than like running an FS watch and doing some certificate management there. But it's also like, is that the right path? And what does this actually, there's so many other pieces that it kind of introduces, which is now the identity of those identity or service account for that pod now has to be able to read the CAs for the cluster.
Yeah.
Because now it needs to be able to do like lots more things, which is right now these control planes are pretty isolated. Like the service account doesn't need to have any credentials to the super cluster to be able to do anything, which is really nice from a security perspective. So Cool. All right, so we are at 10:50. That's pretty much the demo where it is. The code base is up there. I put a WIP tag or a work in progress label on it so that it's not, so it doesn't get merged for right now. I'm still writing tests. There's a little there's a little to-do box or to-do checklist in that that PR. I would love reviews if you want to take a peep at it and see what's in there and how it's all implemented. But it's pretty simple at the end of the day.
Okay, okay, I think that's good. So it seems like at least with your PR is in, we at least have an end-to-end version, or we can make an end-to-end to do with KPN.
Yep. Yeah, it'd be great if we can do a release of it, and then we can start to really integrate. Like the next, I'll actually go after this and file a couple issues, because once we do this, once we have a release of it as like, you know, RC1 kind of thing, we can go in and start integrating this more with ClusterCuddle and see what that true implementation is, and make it so that you could just bring up a kind cluster and then do ClusterCuddle in it with this as a provider and just have it deployed, and you could start using it immediately. So there's some really nice things for like that next step to move this forward.
Cool.
So
that's very cool. I like this integration with the same tool, the same organization, just like plugging stuff.
yeah,
Use most of the things Happy has already implemented.
yeah, the less we have to write. So cool. Do we have anything else we want to bring up or anything like that? Cool. Should we call it then? And maybe next week I'll put an agenda together for next week to basically start to look at what we need to work on next, and we can chat over Slack. Did I lose y'all?